Hey everybody, welcome to the last video of chapter 3, and in this video we'll be going over the concept of Java casting and basically what it is. Welcome back to our channel on Smart Architectural Programming if you're watching on our YouTube, or if you're looking through this video on our accompanying Introduction to Java book. You are almost done with chapter 3 and another one of the important foundations of Java. So let's push ahead into exactly what casting is first. So to start off, we need to understand what is casting, right? Simply in Java, casting is the process of converting one data type into another. Think of it like pouring water from a big container into a smaller one. You need to be careful or you lose some data, and that is what basically casting is. So next thing is implicit. We need to remember there are two types of important casting methods that we need to keep in our mind, which is implicit casting, widening, and explicit casting, which is narrowing. And let's start off with implicit casting first. Implicit casting happens automatically when you assign a smaller data type to a larger one. Let's look at an example basically. So as you can see on the screen here, you'll see that that a double can hold an int. Java automatically converts it without any extra steps. This is safe because we're moving water from a smaller container to a larger container. Double just has more space to contain a larger variety or larger range of integers. So it's a bigger container, and so when we convert int, which is a smaller container, into a bigger container, we pour water from a smaller to a bigger container, the water doesn't overflow and there's no loss of data, and that is basically implicit casting. When you move water from a smaller to a larger container, or from a smaller data type to a larger data type of the similar type, right? Then we have explicit casting. Explicit casting is basically called narrowing as well. Here, let's talk about the explicit casting and also narrowing conversion. This is when we forcefully convert a larger data type into a smaller one. Basically, that's what explicit casting is. And an example of explicit casting, as you can see here, is that we have a double integer which has decimals in it, right? And we're converting it to int. So we're now moving water from a larger container to a smaller container. There is going to be loss of some water there, as we expect, right? So basically you'll see that the decimal point disappears when we print out the converted int, because int cannot store decimal values, so Java simply truncates them. So that's the thing. We lost some water, or we lost some values in the conversion from a larger container to a smaller container, from a larger range of doubles, which consider a larger range of values, to a smaller data type of the similar type, which cannot contain a larger set of values. So let's move on to the next thing now, because I think we understand at this point what explicit and implicit casting is. Implicit casting is just simply moving data from a smaller container to a wider container, right? Or a data which is of the same type, which has a smaller bandwidth, to one with a larger bandwidth. And explicit casting is moving water from the larger container to a smaller container, or data type which has larger range to one with lower range, which usually truncates or results in loss of some data basically. Now that we understand that, let's move on to casting with objects, basically upcasting or downcasting. So casting isn't just for primitive type, it also works with objects. This is where upcasting and downcasting comes in basically. So let's explain this through an example or code so we can explain this in a much clearer concept, right? So basically in upcasting, we assign a subclass object dog to a superclass reference animal, right? So we have an object here which is superclass animal with a subclass dog in it, right? This is safe and automatic, but when we downcast back to dog, we need to do it explicitly with dog, otherwise Java won't allow it. So simply put, basically, if you can assign a subclass object dog to a superclass reference animal, that's upcasting. But and this is safe because a larger animal, dog is an animal. Let's take it like naturally, like that's why I took this example. So we have a class of animals. We have put in animal characteristics in it, and we added a subclass dog, which is an animal because with just a slight tweak to its voice. So we have animal, which a class which says animal sound, but we have a dog class that extends and says that the voice is woof instead. So it's just a basic extension to a unique characteristic of dog, which is also an animal, right? That makes sense. This is safe and automatic, and this is something that makes sense. But When you downcast back to dog, we need to do it explicitly with dog, basically. Otherwise, Java won't allow it. And that makes it slightly problematic, as you can see on line 18, 19, 20. I won't go too much into upcasting and downcasting. There's something that would be addressed more, more in detail when we go into object-oriented programming. But downcasting, generally speaking, you can access dog specific commands, but you need to do it with the specific command of dog in a bracket. Otherwise, downcasting is not allowed. And this is basically a little bit a tricky thing you might need to use in some cases, but it's preferable if you just use the upcasting method to do it much more cleanly, basically. So with that out of the way, let's move into common errors and best practices in Java casting. Basically, you need to understand that casting can be powerful, but it's easy to run into errors, as most people do, especially if you're doing explicit casting or narrowing, right? So you need to be careful there. So some of the best practices around that is to always try to cast incompatible types. Will result into class cast exception. Always remember that if you try to cast a string into an int or an int into a string, that's going to happen. So it needs to be, casting must be done with compatible types in most cases. If you're doing incompatible casting, it would raise a class cast exception error in Java. Number 2, always check with instance of before downcasting to avoid runtime errors. And so with that, let's look at a code example here. As you can see, that's basically how you need to do test using instance of before downcasting to avoid any runtime errors that would happen. See, downcasting is always a little bit awkward, so you need to have some safety measures in place to make sure downcasting doesn't create chaos or errors in your code. So that's a wrap basically on casting in Java. Understanding how to properly convert data types and objects will make your coding smoother and more efficient. If you found this video helpful, don't forget to like and subscribe and hit the notification bell for more Java tutorials. Also, if you're following along in our accompanying Introduction to Java book video series, you have completed chapter 3, and good job, because you are one step ahead in mastering Java and one step ahead in understanding the fundamentals of Java. So with that, we're going to wrap this video, and I will see you in our next video. Thank you.